start presenting, I guess. So we get the title and show all. Let's wait for all the people to come here, but it's your time to shine.
All right, let me start by making sure I share the correct screen, which is half the battle. Share. And are you seeing my slides and not
Yes.
Zoom? Excellent. All right, we're off on a great start already. You just let me know when you want me to get started. It is exactly 10:30 Eastern time, according to my clock.
So on the clock. If
all
you
right.
want to give like 30 seconds academic time for people to come in, or you can just go. It's recorded. People can get back.
Let people finish getting their cup of coffee. That's very important.
I'm actively brewing my Nespresso as we speak.
I had to lay off on the coffee as I got some new coffee beans from a local coffee roaster yesterday. I made them up this morning, and I'm just like, woo, those are strong. So that was some good coffee today.
I love it. I love it.
Well, I hope everyone that is joining us right now for this session is having a great day, no matter where you are in the world, and whether you prefer coffee or tea or Coke or none of those options. So I'm Jess Schultz, a software engineer at Microsoft, and today for about the next 75 to 85 minutes, I will be talking about which Azure SQL database options should you choose. So I just want to kick off with a few GroupBy slides. So this is my first time presenting at a GroupBy conference, so I'm excited that I was selected. I'm excited to be part of the speakers now. Just a reminder that we do have a code of conduct. We want everyone to be able to attend and express themselves and do it safely. This is a safe space. If you have any questions about the code of conduct, please go to the URL at the bottom. I also want to extend a thank you to the GroupBy sponsors, SolarWinds, Redgate, Straight Path Solutions, Pure Storage, and Dallas DBAs. Without them, this wouldn't be possible. I hope that when you signed up, you opted in for information from one or more of those sponsors. Again, they make tools that make your life easier. They offer services that make your job easier. Well worth spending some time to learn about them. And for those of you that I have not met yet, again, my name is Jess Schultz. My pronouns are she and her. I'm a software engineer in commercial software engineering at Microsoft. What does that mean? I work in an organization that deals entirely with Azure. That's my life. So I help my customers when they are either moving existing applications or building new greenfield apps in Azure decide what data store to use. Azure SQL is one of our premier options. And in this particular session today, what I'm going to be delving into is the myriad choices that you have when you choose an Azure SQL database. Many of you are probably familiar with and love, like I do, SQL Server. But when you go to pick SQL Server, you choose a version that's supported, like SQL 2017 or SQL 2019. Install it on the physical or virtual machine that you may have requisitioned from your administrative department, and then just install your options. When you go to choose Azure SQL Database, you have to choose from far more terms and choices, and I just want to clarify those for you and give you use cases for each of them. We will be looking at some PowerShell scripts that I have to set up all of these options as well. So I link here with my email, Twitter handle, and GitHub URL. You'll want that. I'll also, again, show that at the end so you can get the slides that I use here and the scripts from my GitHub repo. So with that, let's get into the good stuff. What is Azure SQL, right? Like, what differentiates it from SQL Server? Azure SQL is not just the box product SQL Server running on a machine in Microsoft's cloud, Azure. When we talk about Azure SQL, we're really talking about our fully managed platform as a service relational database based on the SQL Server engine. The benefits of a platform as a service offering, which I'll talk about more on the next slide, involve things like Azure handling OS and SQL upgrades, patching, backups, high availability and disaster recovery. Azure SQL allows us to give you a cloud-first development experience, meaning that many of the new features that you see in SQL Server, particularly in the engine itself, come to the cloud first and then are put into a box version of SQL Server. So you're always getting the latest, the greatest, the newest updates first. And we're doing this with 4 nines of availability across the board. Delving in a little bit more into this platform as a service offering. Again, cloud first development is really the name of the game. Features that have come into Azure prior to coming into the box product include things like query store. It includes things like our auto tuning and auto indexing options. These are things that are easy for us to develop in the cloud at scale and then prove out, improve upon, and put into SQL Server. When you choose the platform as a service offerings for Azure SQL, there's a lot of administrative functions that are taken care of for you. We really want to take the burden of administration off of you, allowing you to focus on performance, innovation, modernization, and improving your applications. So backups are performed automatically. Full backups, differential backups, log backups. And they're easy to restore either through the portal or through PowerShell or CLI. High availability is always built in. We have multiple copies of your database available in your primary region. And disaster recovery for a database is easy to set up and use. At its most basic, your backups are stored in a second paired region. So if your primary region were to go down, you can restore those backups into a secondary region, but you can also choose to set up, failover groups, for example, to have that database automatically available in a second region. One of the biggest benefits of Azure SQL and really many of our platform as a service data store options in Azure are that ability to easily scale up or down. Thinking back to the on-prem days of physical hardware, if you had an application that got more popular or a server that had more databases added on it and you needed more memory, that could take weeks or months to requisition. Even in the world of virtual machines, it was really easy to, or you could have perhaps asked for more cores or more memory, but that could take some time to get that, shuffle around all the virtual machines. In Azure, if you need more compute, if you need more storage, request it. It often happens in less than a minute that you're up and running on the higher resources. But we also have the benefit of being able to scale down, which is great because there's these cost savings. And something I actively encourage people to look at, be monitoring your resources. know when your application is using less than 50% or less than 25% of the allocated resources. Scale down if you don't need it. And we have some really great performance monitoring and improvement tools in Azure SQL. Query Performance Insight, which is based off of Query Store, and in the Azure portal lets you see what some of your top resource consuming queries are and how to make them better. We can turn on automatic plan correction to help with things like parameter sniffing and really variable plans. We can turn on automatic index tuning to help with creating non-clustered indexes that would improve your query or your database performance, and also removing unused indexes. So this is a lot of the reason that I tell people Azure SQL is great, right? Again, taking a lot of the administrative functions away from you, things you don't have to worry about, allowing you to focus on the performance, the modernization, the improvements. But getting started with Azure SQL isn't just go into the portal or go into PowerShell and say, I want an Azure SQL database that's a terabyte in size and has 2 cores. We have a lot more choices that you have to make these days. 11 years ago, when Azure SQL was V11, right? It's hard to believe it's been 11 years. It was that simple, but now we have to think about things like, what is your deployment option? So how are you structuring your server, physical or logical, and its databases? What purchasing model are you using? So how is your company going to be paying for this? Within your purchasing model, what compute power do you want? And even then, in conjunction with your compute tier, is your compute provisioned, available 24/7, or is it serverless and on demand? And everyone can see that Henry has joined the presentation. Hello, Henry. My cat's new favorite place is my desk and my keyboard, so I apologize for that. The joys of presenting from home these days. So I'm going to be covering how deployment options, purchase models, service tiers, and compute tiers tie into things that you have heard, like managed instances, DTUs and vCores, general purpose and business critical, hyperscale, provisioned, serverless, all of those things. This chart that I have made has been one of the most useful in explaining these options to my coworkers and to customers. So if you take nothing else away from it, taking a screenshot or printing this out and hanging it on your office wall could be very helpful. This really is a kind of a decision tree. So we start from the top and decide, are we going to be deploying SQL Server in a virtual machine? Or will I use a managed instance? Or does a single database work? Or do I need an elastic pool? I'm going to talk about the differences between all of those options. Once you've chosen how you're going to be deploying the database, then you make that decision about the purchasing of the compute. For some options, you have DTUs and vCores. In some cases, you only have vCores. Underneath your compute and in conjunction with your compute, you also need to decide your service tier, which is basically how are you, what kind of storage do you want? We have general purpose, we have business critical, and we also have our newest offering, Hyperscale. So I'm going to point out what the differences are between those 3 tiers, and again, use cases for them. And then in single database, vCore under general purpose, so this one very specific offering right now, we also offer the option between provisioned and serverless compute. And I'll be talking about the difference and use cases for each of those as well. If you do have any questions in the meantime, I have my chat popped up, and I'll have Emmanuel interrupt me if there's anything that's really important that I need to cover right then and there. Please feel free to ask questions. I am here for you to pick my brain on this as we go along. All right, so all right, so under what we're primarily going to be focusing on today for deployment options are the platform as a service offerings of managed instance, single database, and elastic pool. But before we jump into that, I do want to talk about running SQL Server in a virtual machine in Azure, because this is still a perfectly legitimate option, and it is still something that a lot of customers are using for many good reasons. When you choose to run a virtual machine, here you're using a full version of SQL Server. So you install it using the same media, the same processes that you do, on-prem, either physically or in a VM. You can use Windows or Linux as the operating system. If you have Windows OS underlying your SQL Server, you can get automatic Windows updates, automatic SQL Server updates, and even automatic backups. So those don't come by default, but can be enabled to give you more of that automatic administration that would be closer to a PaaS offering. SQL Server in a VM is really good for a true lift and shift. So you may have an existing SQL Server on-prem, the company says we want to move the app and the databases into Azure, minimal code changes, put it into a virtual machine. Typically, if you're doing that, you really just need to change things like connection strings. Another benefit of SQL Server in a VM is that it allows you to run the SQL Server adjacent features like integration services, analysis services, machine learning services, reporting services. If you have a complex ecosystem and are not ready to convert things like cubes to Azure analysis services, or don't have time to rewrite all of your SSIS packages into Azure Data Factory pipelines. So again, SQL Server in a virtual machine is still a great option for lift and shift, still used by a lot of customers, but I'll be focusing more on our platform as a service offerings today. So the first one, which is really a great hybrid between running SQL Server in a virtual machine for the full SQL Server instance and an Azure SQL single database, which does not have 100% compatibility, is a managed instance. Managed instances are a collection of the system databases like master and MSDB and the user databases you restore or create, and they have a shared set of resources. So all of the databases share the number of cores, the amount of memory, the storage that you provision. When I say it's lift and shift ready, it's because it has almost 100% compatibility with on-prem SQL Server. Currently, the list of things that are not offered are things that are being deprecated, like database mirroring. There are some other things like file stream, which requires the underlying file system. There's some Windows authentication because we use Azure AD authentication instead. So very small list of things that are not supported, and it's typically for other infrastructure reasons. The best use case for managed instance is being able to lift and shift existing on-prem SQL Server, either a few databases or an entire instance, and getting that full platform as a service experience with it. once you deploy a managed instance, it's a full instance. You have your server name, you have all its databases underneath it. They all share the resources. They have an almost 100% feature compatibility. There's a lot of tools that we have available, different migration tools to enable that migration as well, so that you're not, restoring 50 or 100 databases individually. Managed instance does allow you to use features of SQL Server that aren't made available in our single database and elastic pool deployment options. Big reasons that customers choose managed instances over single databases or elastic pools are typically cross-database queries. That's something that's not natively allowed in single databases and requires some extra work in elastic pools. So if you have a lot of related databases, apps that frequently join tables from different databases or make a lot of cross-database calls, managed instance is a great choice without having to re-architect all of that. SQL Server Agent, not available in single database or elastic pools. You have to build something else using Azure Automation or Azure Functions. So if you have a lot of non-administrative tasks that are built into SQL Server Agent jobs, managed instance might be a better tool for you. And then there's other instance level features like Resource Governor and Service Broker that are available in MI, but not single databases. So essentially, when you want the platform as a service offering and you have existing databases either on premises or in an Azure VM, and you want to move them to platform as a service with as little code changes as possible, managed instance is a great choice. The caveat with that, because as Robert Heinlein would say, Tanstoffel, there's no such thing as a free lunch, is managed instances are much more complex to set up than a single database. Managed instances need to be deployed into a virtual network. You need to have an empty subnet. It needs to have a bunch of these specific networking rules applied. So just be aware going into it, the setup on the front end is a little bit more complex because of that. That's cost benefit analysis there. So that's managed instance, again, kind of that bridge between a full version of SQL Server in a VM and single databases. What is known now as a single database in Azure SQL was the original Azure SQL. It is simply a relational database based on the SQL Server engine that has its own set of resources. Every single database in Azure SQL is tied to a logical SQL server. You'll notice here on my slide that the word server is in lowercase to differentiate it from SQL Server, the actual product. A logical SQL server controls a lot of security options. That's essentially where you set your admin usernames and passwords or admin AD groups. It's where you set firewall rules. So keep in mind that you'll still need to manage a server level. Single databases really shine when developers want to build a new cloud native application. They're familiar with SQL Server and they want all of the, indexing power, all of the rich feature set that's available in a SQL database. So again, single database is best when we're doing a new greenfield application for a cloud app, or also a simple database, again, something that doesn't have a lot of cross-database dependencies, something that doesn't have a lot of tied in logic through integration services or through agent. Also, we do have a lot of tools for migrating, not just from SQL Server to a SQL database, but you can also migrate from, MySQL or Postgres to a single database. And then there are elastic pools. So elastic pools have the feature set of a single database, but one or more databases are put in a pool of resources and shared. So as you'll see when we start getting into the compute option, when you provision a single database, you can say, I want 4 cores, which associates with 32 gig of RAM, and I want, 2 terabytes of storage. All of those cores, all of that RAM, all of that storage resources goes to that one database. But there are times when you might have a pattern where there's a set of related databases that can share resources, rather than setting up 100 single databases that all need 2 vCores and all need 4 gig of RAM. You could set up a pool to share a bunch of cores and RAM. This is really optimal for multi-tenant databases or software as a service applications. The multi-tenant app would have many databases that have the same schema but varying usage patterns. You might have one database per customer, one database per supplier, one database per division around the world of your company. An elastic pool includes tools, as you see over here on the right side of the slide, called the elastic tools that allow you to do things like write queries that run across all of the databases, set up jobs that run across all of the databases. So those are the main differentiators between SQL Server and a virtual machine. That's the full 100% SQL Server option in the cloud. Managed instance, which is the closest to 100% full SQL Server compatibility and comes with just a little bit more networking and other setup right up front. Single databases, which are optimized for cloud native applications, and elastic pools, which are a collection of single databases that share resources. Those are your deployment options. One of the first decisions you'll have to make when creating an Azure SQL database. I do see one question in chat asking if SQL Server Master Data Services, or MDS, is coming to Azure as a platform as a service solution, or is that something that you would need to run SQL Server in a virtual machine for at this point in time? Right now, there's no master data services offering, so that's something you would want to spin up a virtual machine for. All right. We've covered the first level, deployment options. You now have a clear idea of what options you need for your database. You have an idea of what platform as a service parts you're going to take advantage of. Now you need to decide how you're going to pay for it. So what is going to be your purchasing model? All right. We have 2 methods, DTU or vCore. DTU, or Database Throughput Unit, is the older version. This is what single database ran on for a long time. Now, in the last few years, we've also introduced vCore. That's the standard model. That's what managed instance runs on. That's what single database and elastic pool run on. I mentioned DTU more for reference than anything. We really recommend going with vCore. the big difference. DTU, when you pay for DTU, you're paying for a blended CPU, memory, and storage option. If you have a small database, say it's only 10 gig, but it has a really high number of transactions and needs a lot of CPU, you have to pay for a high DTU tier. In vCore, however, your compute and your storage are scaled out separately. So if you have a very large database that has very few number of transactions, just pay for more storage and less compute, and vice versa. So we'll go into all of these options. Let's see, I have a question in Q&A. There's a question in the Q&A about pricing for elastic pools, and I like to say when I'm giving presentations that there's a good question and a great question. Good questions are ones I know the answer to. Great questions are ones that are going to be answered on a future slide. So that's a great question. We'll find out that answer in just a minute. So again, DTU is older, but I mention it here in case you see it in documentation. Most customers are going with vCore for their needs now. So in the purchasing models, there's different service tiers available, basically just how much compute you can get. DTU had 3 levels, basic, standard, and premium. In vCore, you have several different compute choices. This is very similar to running a virtual machine where the virtual machine compute option you choose is what processor is behind it, how fast are the processors, what type of memory is it. So you can see we have Gen 5 and M series and DC series. And then again, vCore, because your compute and your storage are broken out separately, your storage gives you the option of general purpose, business critical, or hyperscale. So let's talk a little bit about DTUs. First, I won't touch on this a lot, again, older, but in the DTU model, your basic, your standard, and your premium, your tier determined how many database throughput units you got. So how much work can your database do in a second? It determined the maximum size of your database. Again, if you had a 2 terabyte database that wasn't busy, you had to go to the premium model because standard topped out at 1 terabyte. And again, because your compute and your storage were tied together, your IOPS were tied to the number of DTUs you had. So if you needed a lot of IOPS on a small database, you still had to go into premium because it offered 25 IOPS per DTU versus 4 IOPS in standard. In the elastic pool model, so for eDTUs, you paid for compute, memory, and storage as a chunk. And if you paid for, say, the standard model, you picked the basic option there, you could have up to 100 databases in the pool. You would get 50 elastic DTUs, and it's capped out per database. So to answer the question that's in chat, do I get billed for each database plus the elastic pool price? In the DTU model, everything's combined, the storage, the compute, and the memory. In the vCore model, you pay for your compute for all of them and you pay for the storage separately. All right, so let's talk now about the newer model, the vCore. I'm not going to go into each of these specific choices, but you see that the compute, which is on the left, gives you a range of the number of cores and the amount of memory that you get together. The FSV2 series is CPU optimized. The M series is memory optimized. That lets you pick the best compute for your workload. We also recently introduced a hardware series designed for confidential query processing, basically enabling secure enclaves for always encrypted by default. Then on the right column is your storage. So we have general purpose, business critical, and hyperscale. General purpose is great for non-production workloads or very low throughput production workloads. In general purpose, your compute sits on one rack of hardware and your storage is premium blob storage. So there is additional latency as your compute has to go out to blob storage to get the data and bring it back. Less expensive, higher latency. For production workloads, business critical is recommended. So here, your compute is on this cluster and your storage is locally attached SSD. That's the difference between those terms in storage, general purpose and business critical. So again, when you choose either a managed instance or a single database or an elastic pool, and then within that, you choose to pay for things by vCores, you choose a compute option from the left and a storage option from the right. So I hope all these terms are starting to make more sense now. And I'm going to introduce a new one called Hyperscale. So Hyperscale is a kind of a combination of the compute and the storage options. It's been around for over a year now, but it is still one of the newer options in Azure SQL. It does not have an equivalent in the SQL Server box product, so this is unique to Azure. Hyperscale for the storage combines both SSDs, SSD and Azure Blob storage, and offers storage scaling. It is built on our Gen 5 hardware platform. But what makes Hyperscale unique is that it is a distributed functions architecture. So what this means is there are 4 primary services that make up Hyperscale. Instead of the database engine sitting on the same hardware that your log writer service does, or your transaction log does, and then also shares the same processing and memory power with your plan cache and your other cache and also your main database file, we've actually broken this out. So there is first the compute layer. Let me get out my fancy laser pointer here, or my pen even better. Number 1, I don't know if I can find it here on my screen. There we go, I'm over there, bring it over here. So we start with compute nodes. You have one primary read-write compute node. This is where the database engine, SQL Server.exe, lives. Included are some read-only secondary compute. So by default, Hyperscale allows you to scale out reads. Now, your MDF, or your database files, are down here way off in this just Azure storage container. One of the benefits of this hyperscale model is that backups are done via snapshots at the storage level, meaning they are nearly instantaneous. So not a size of data operation any longer. Same thing with restores. We restore snapshots. So not a size of data operation. So if you have ever had the very painful experience of having to do a restore where there are a lot of rollbacks and things took forever, that problem can be solved by being in the hyperscale model. Now, in between your SQL Server.exe and your actual data file is all of the other stuff, right? We have to write transactions to a transaction log. We then have to write those into the actual data file. That's where our third piece, the log service, comes in. The transactions are written from our compute node to our log service in Azure Premium Storage. And this service here handles updating the MDFs, updating the cache, which leaves us with, when we read our data from disk into memory so that we can use it to fulfill our queries, where does it go? It goes into the page servers. So we have multiple page servers per database. There's a formula out there for the number of page servers based on the data size. I don't know that off the top of my head, but each page server is responsible for a subset of the data in cache, and that is kept up to date by this log service. So the main benefit of hyperscale here is that, again, it's a distributed architecture. We have separate pieces that handle the compute, the writing of the transaction log, the fulfilling of the page servers. Hyperscale is really cool when you have really large databases. So use cases for hyperscale. Number one, as you've seen in previous slides, if you were paying attention, all of the other storage models like general purpose and business critical and the DTU models tapped out at 4 terabytes. With hyperscale, because we're using that underlying Azure storage as the base for the MDF, you can do databases of up to 100 terabytes in size, a huge leap forward. Hyperscale, because of its distributed architecture, also enables much higher throughput. At any tier, even if you have 2 vCores, you can get 100 megabits a second of log rate. That does not matter if you have 2 cores or 16 or 64. You do not get that ability with general purpose or business critical storage. With those other tiers of storage, lower vCores mean lower log throughput. So if writes are one of the primary drivers in your workload, and that's been a bottleneck for you on previous versions of Azure SQL, hyperscale might fit that need. Also, again, the built-in read scale-out multiple read replicas can be really useful for databases that need to separate out the read-write patterns from the read patterns. So check out Hyperscale in Azure SQL if you have a database that fits these requirements. All right, so I've helped you, I hope, figure out the difference between your deployment option. Again, are you deploying into a virtual machine, into a managed instance, or into a single database or pool of databases? I hope I've helped you understand the different compute and storage options. Are you choosing that blended DTU or the separate compute and storage of vCore. And then if you are using vCore, what level of storage are you choosing? There's one more choice that we need to make, and that is within our compute, the compute tier. Now, this is a newer offering, and it's limited at the moment to the vCore general purpose. But if you choose that option for your compute, you can either choose that it is provisioned or it is serverless. What's the difference? Provisioned is the standard model. This is where you say, I want an Azure SQL database. It's running on general purpose storage, and I want to pay for my 4 vCores with their associated amount of RAM and my 100 gig of storage 24 hours a day, 7 days a week, 365 days a year. I know that my app is mission critical. I know that there will be constant demand for it. I want to be billed hourly. But that is not the pattern of every single database that uses Azure SQL. Sometimes you have databases that might be used, for 2 hours out of a day, and then are not used for the other 22. You might have something that's used on the 1st and the 15th of the month, like some sort of payroll software very extensively. And then the other, 28-ish days of the month, very, very low usage or none. You might have a database that's used a month out of the year, 2 months out of the year, and is idle otherwise. In the standard provisioned model, you would pay for that compute because the database exists. Up until serverless became available within the last year, I frequently would have customers that would be like, okay, so what kind of, if I use Azure SQL, what kind of thing do I need to spin up so that like when my database hasn't been used for a day, it like gets backed up and pushed off to Azure storage. And then when I need it again, I have to spin up some sort of Azure automation to rehydrate the database and make it available in as little time as possible, because I don't want to pay for those DTUs 24/7. I don't want to pay for those vCores 24/7. That's one of the features that serverless can solve. So because it uses the vCore model where compute and storage are separate, if you want it to be serverless, you say, okay, I'm going to pay for the compute while my database is active. If it's not active for X amount of time, and you get to choose that amount of time, then the database, the compute goes inactive. You're no longer paying for the compute, you're just paying for the storage. The next time a request is sent into the database, it comes up, your compute is spun up, it's connected to your storage, and boom, your app is off and running. So that's one feature of the serverless. The other benefit of serverless is that you can do some auto scaling within it. So when you choose the serverless option, which I'll show you on the portal so you can envision this during my demo section. When you choose the serverless option, you also get to choose a minimum number of cores and a maximum number of cores. So you could know that when that database is active, you know that it's reasonably critical. So you say, when it's active, I always need 4 cores, or I always need 8 cores. The other flip side of serverless is the auto scaling. So you could say, when it's not busy, I want to pay for 1 vCore. When it is busy, I want to give it all it has, so set this to 16 vCores. And then as your transactions go up, it automatically scales up your vCores. As your transactions goes down, it decreases the amount of vCores. So this is the one tier we have that does the auto scaling, where you don't need to worry about writing a bunch of custom logic, again, in a function or in Azure Automation to have that done. And here in serverless, you'll note your compute is billed per second rather than per hour. So a little bit different. So use cases for the serverless. Again, databases that are active for a short period of time, in a day, in a week, in a month, and then idle for a long period of time. If you move it into the serverless model, you only pay for compute when it's active. You pay for the storage all the time. Databases that have varying levels of activity and could benefit from auto scaling. The flip side of this, much like I said with managed instance, right? Like you have this great set of options and features, but you have to do a lot more work with the network. How serverless does what it does is more aggressive cache mechanisms. So understand that in order to be able to scale up aggressively, scale down aggressively, in order to be able to handle the varying workloads, there are more aggressive caching rules in place. You might not have as big of a page cache available to you. So read up on that carefully and just understand the trade-offs that you're making there. But it does solve some very specific problems. All right. So we have covered that under Azure SQL, we have different deployment options of managed instance, single database, and elastic pool. Under each of those deployment options, you choose how you're paying for it, whether that be the older database throughput unit model or the newer and honestly preferred vCore model, where compute and storage are scaled out separately. Your compute options are, the Gen 5, the M series. Your storage options are things like general purpose, business critical, and hyperscale. And I talked about this one very specific wedge where you can get some serverless options. Hopefully those will be expanded in the coming months. Before I move into demos and showing you how to set some of this stuff up and where that is, are there any outstanding questions? Please feel free to put them in the chat or the Q&A. Nothing yet.
I think we took care of them during your presentation, and to me everything is like super clear. You are like the most structured presentation of this I've ever seen.
Well, thank you. I really, like I said, I put together that diagram about a year ago for a customer engagement, and a couple other of my coworkers saw it and they were like, oh, it finally makes sense. And so I try to use that in as many engagements now as possible. All right. If you do have questions, please, again, continue to put them in the chat. I'm going to go through and show you now how we go about creating some of these things, where you'll see the options, and then I'll also show you not just how to do it on the portal. The portal is, my analogy of the portal. Back in the day when I started as a SQL DBA, I would go into SQL Server Management Studio, and if I needed to restore a database, I would right click and say restore, and I'd fill out my options, and then I would say, and I would run it, but then I'd also script it out and look at the actual T-SQL. If I wanted to create an index, I would do the same thing. I would go into Management Studio, right click a table, create index, fill out all my things, script it out. So I saw the T-SQL. It helped me learn what options were available, but it was not very efficient. Same thing with the portal. Digging into new features in the portal is really great for helping you figure out what options are available. But if you need to create 100 Azure SQL databases and you try to do it in the portal, at this rate, I feel like the world will be back to working in offices on a regular basis instead of at home before we get there, which is why you want to learn how to automate these processes using a programming language, typically PowerShell. I'm going to show you PowerShell because I know and love PowerShell, and I hope Rob Sewell is listening so that he heard that. He's our next presenter in this track. But it is available in like CLI as well. So I do have a question. Am I going to cover Azure Synapse as well? It was formerly known as Azure SQL Data Warehouse, which is a SQL product. I am not. That's another entirely different presentation. I have limited amount of time to cover this, so I apologize for that. All right. So in the Azure portal, if you want to create an Azure SQL database, you can come up here to the top left, say create a resource, and just type in Azure SQL. You're going to see Azure SQL Managed Instance, Azure Arc. We can also just say, I actually don't type this very often, so you guys are just kind of coming along on a fun ride with me through the portal today. SQL Database, there we go, SQL Database. The other thing that you can do is here under Creator Resources, we can do categories, go to databases, and you'll see here SQL Database or Azure SQL Managed Instance, or remember what I said, SQL Server Logical Server. You can also find under All Services, for those of you that don't have this pinned yet, I have over here on my shortcut menu, my Azure SQL, and I'm trying to remember how I got that there. So if you go to All Services, and again, we go down to Databases, you'll see Azure SQL, which is the blade. So Azure SQL is, so we have Managed Instance. We have Single Database. We have Elastic Pool. You can create each of them. You can manage them separately. Or we have what we call the Azure SQL Blade, which allows us to see the logical SQL servers, the individual SQL databases, the managed instances all in one location. So search for and favorite and use Azure SQL as an easy to use location. Now, if I want to create something here, I click create and it's going to give me different options. So here I have an option for a virtual machine. And I could choose, you'll see SQL Server 2019 on Windows Server 2019. You see SQL Server 2019 on Red Hat Enterprise Linux, Ubuntu, Swiss, SQL 2017. So here's an option for getting started with automatically created images. Here is how we can create a SQL managed instance. If we were to say create for a managed instance, you'll notice that we have to fill in things like our resource group, a name, a region. You'll see we choose our compute and storage here. So configure managed instance. The only option I have is the vCore, right? You don't see anything about DTU anywhere. Again, older model, general purpose, business critical. So again, that little diagram is starting to make sense. You start at the top, work your way down. You choose what hardware you want, your cores, backups. I'm not going to change anything off the defaults here. It's when we get next into networking. Again, you have to make sure that you have you either have pre-created a virtual network and a subnet that have all of the requirements met around number of available addresses, CIDR notations. You have to have your what's the word that I'm looking for? Sometimes in a presentation, my brain just completely forgets the thing that I'm looking for. You have to have your networking set up ahead of time. In short, you have to know if you're using public or private endpoints, all of that. So there's a lot more that goes into managed instance networking than single database networking, as you'll see soon. Your additional settings, again, we're setting up a full SQL Server instance, essentially. So you do get to choose things like what collation my databases will be, time zone that you want it to be by default, georeplication, which is your disaster recovery, can be set up right here. This is newer. You can now select a preferred maintenance window, tag things, review and create. So this is validation failed. What did I do? Oh, totally missed this. One thing to note about both managed instances and SQL Server instances, when you go to create them, you always need an admin username and password. This is essentially equivalent to the SA in a SQL Server instance. After a SQL login is created, and your password is typed in sufficiently long, meets all the requirements, and you can make it match. So it will create your instance with this SQL username and password. You might not want that. You might want to use only Azure Active Directory authentication. You want to use service principals. You want to use groups. After your instance is created and your SQL authentication is created, then you can set up an Azure Active Directory admin. That admin can create other users, the groups, the permissions, etc. All right, I'm not going to click create here because you'll notice my estimated cost per month is $1,700 US minimum, and it will take quite a bit of time to deploy. But going through the portal, those are your options for managed instances. Let's compare that to setting up a SQL database, just a single database. So when I go to create a single database, okay, typical Azure work, I need to choose my resource group. I need to give it a, so now instead of entering a server name, you'll notice I'm picking that in the next box. I have to just enter my individual database name. Then I choose what SQL Server. So this is that logical SQL Server, that grouping of single databases or grouping of elastic pool databases that I'm choosing. I want to use my Schultz test server. Here is where I can choose if I want to use an elastic pool. In this case, I say no. I'm just building one database. Then it's going to ask me about compute and storage. Default is to pick general purpose Gen 5 to vCore. But let's go to configure and see what our other options are. Here, if you did want to go with the DTU models, you can find them under basic, standard, premium. Again, not really common anymore. Our recommendation, being Microsoft's recommendation, is to use vCore. My personal recommendation is to use vCore. Again, compute, your CPU and memory is one option. Your storage is another. You can scale up, down, left, right without it all having to be tied together. You'll see we have our options here of general purpose, business critical, or hyperscale. I would probably choose business critical, again, for any production workloads I have. You'll notice when I choose my storage option, so I choose whether I want general purpose or business critical, then I get to choose what hardware I want. Again, change configuration. I can choose memory optimized, confidential compute, balanced, or Gen 5. I'll stick with Gen 5. I know that sometimes this, so I pick the slider to choose how many cores that I want. I can choose my max size. This is why I say that using the portal to create a database is much less efficient than my PowerShell scripts, which we'll see in a moment, because I could spend an hour clicking in and out here. You'll see that I have the choice for enabling read scale out. I'm going to disable that. I don't need it right off. I don't need to make it zone redundant. I click apply. All right. I get to choose my backup storage, redundancy. Under networking, you'll see this is much different. There's nothing about virtual networks here. Firewall rules, they come from our logical SQL server that we attached to. I'll show you how to create one of those as well. You can, however, now set up a private endpoint for your database. So that means that your database would be assigned a virtual network and an IP address within that virtual network, so your apps could connect to just that one IP address. Security, you can choose to add on Azure Defender for SQL. Under additional settings, you'll notice that you can start with no data. You can start with a backup of an existing Azure SQL database, or if you're new to Azure SQL and you want to play around with this, you can come in and create a sample database. It uses AdventureWorks. I think that this is really a good introduction. If you're used to playing around with like SQL Server, AdventureWorks to test new features, and you're just dipping your toe into the Azure SQL waters, come out here, create a small database on general purpose storage, Gen 5 with 2 vCores, create a sample database, play around with it. Your database collation is coming from your SQL Server again, but you can change it here. You get to choose your preferred maintenance window if you want it, and then you can review and create. A lot of options. I hope that now, having walked through the presentation, when you're walking through all of those screens, you understand the differences. All right, so I do have a question in the Q&A. Cost seems far higher for vCore general purpose. What are the major advantages? I'm not sure what that means in terms of cost seems higher than what? If you're directly comparing the DTU model and the vCore model, the vCore, they're not direct one-to-one comparisons. Again, the DTU has that blended compute, memory, storage. I would say that there are vCore breaks out the cost between the compute and the storage more easily. It does allow you to choose, maybe I want more compute, but I only need general purpose instead of business critical storage. That's the main advantage in choosing the vCore model. You get to scale those things separately. You also get higher resources available to you in the vCore model. So those are some of the answers, or those are some of the advantages of vCore. Might seem a little bit more expensive, but in the long run, it gives you a lot more flexibility. Another question I get pretty often is, I have existing databases in the DTU model. Can I convert them to the vCore model so I can scale separately? The answer to that is yes. Out in our documentation, I never seem to have the link available when I'm giving this presentation. Note to self, write that link in. There is an article out there. We do have very specific instructions for how to convert your existing DTU databases to the vCore model. All right, so that was how to provision databases through the portal. Again, great for learning, not great for consistent reuse. So with that, I'm going to show you some PowerShell scripts. So if you're looking for these, I have a GitHub repo. I've had a GitHub repo for quite some time, and I'm actually getting more repos on it. You can come out to github.com/grrlgeek, GRRLGEEK. Again, this link is at the end of my slides. You can come to my Azure SQL Server repository, and a few things you'll see here. The different presentations I give on Azure, slides will be listed here. And you'll notice I have a bunch of different scripts available. Some are a little bit outdated. 2 years ago, haven't done those in a while. Others are much more recent. I'm going to focus on showing you new AZ SQL Database, which is deploying a single database, new AZ SQL Elastic Pool, for Elastic Pools, obviously. We'll talk about new AZ SQL Database Hyperscale. So you can see that there's not much of a difference there to deploying that. And then new AZ SQL Instance, which shows you the managed instance. And this is where you'll see that the portal covers up a lot of hoodoo voodoo magic that goes into the managed instance and the networking, so you can understand the complexities. So I have cloned my repo to my computer, and I have opened it in VS Code. So that's the tool that I'm using to see my PowerShell scripts. If you're not familiar with VS Code yet, powerful code editor. It's where if you had told me 2 years ago that I would be in VS Code every single day, cloning repos and writing PowerShell scripts and Markdown files and Java, I probably would have laughed, but here I am in VS Code every single day. So this is just one of my tools. All right, so let's review new AZ SQL Database. Things that you will have to do. You'll have to connect to your Azure account to run it, because all of this uses AZ SQL, which is going to use my single sign-on, which will take just a moment. Authentication complete, sweet. All right. Once you're connected, you choose your Azure subscription, just in case you have multiple. Output. Helps if you actually run the command. There we go. I know that I want this subscription ID, so I fill that in as my variable, run that. Other things we need to do then within that resource, within that subscription, we need to get our resource group. Am I going too fast for this? Yeah. So I have a bunch of resource groups set up. I want to choose that one that I've been using all day, the RG SQL Database. Yep, put that right in here. Assign my resource group and region variables. I do include the command for if you need to create a new resource group. That's how you would do it. Within the resource group, then again, you need this logical SQL server to tie your databases to. I can see that within this Within my RG SQL database group, I have DBA VUG and J Schultz test. I'm going to tie myself to my existing J Schultz SQL Server. Again, if you need to create a SQL Server, I've included the commandlet there in which you pass in a resource group, the name you want to give it, and the location. When you run this commandlet, a prompt will come up that asks for a username and password. As I explicitly list in my code, this is not your Azure credentials. This is that admin username and password that the portal asked us to enter. So you want to enter a username and a password. Make sure that password is stored securely, or use the SQL Administrator Credentials option and use get-credential to fill it in. I also highly recommend storing your SQL Server admin name and admin password in your key vault for easy retrieval. Another thing that you need to do in your server is set your firewall rules so that either your computer or the applications that need to connect will be able to go through. You'll see I have a few firewall rules set already. Client IP. You'll see that if you need to set a new one, it's new AZ SQL Server firewall rule, and you pass in either a specific IP or a range of IPs. Once you have all of those pieces in place, then we can actually create the database. So the information we pass in, a database name, that's the most important. I've given you the options for both DTU and vCore. We'll pay attention to vCore. So when you're creating so eventually we'll want to be running this new AZ SQL database command, but here's all the things we need to add in first. Addition is your storage, general purpose or business critical. vCores are the number of cores you want. And then your gen is the hardware options, right? Your compute Gen 5 or your M series. Once you have those parameters all set up, you can run new AZ SQL database, pumping all that in, and it's running. So as I hope, as you can see, this is much faster than using the portal because there's not click here, drop down there, etc. Yes, you do need to know a little bit about what additions are available, what vCores are available, what generations are available, but you can look out on the portal for that, or you can look in Microsoft Docs for that. I also tend to think from purely observatory experience that it's faster when you submit via PowerShell versus doing it on the portal. All right, so let me give you a couple comparison scripts then. Hyperscale. Again, Hyperscale is technically just a different, under vCore, just a different compute and storage model. So you'll notice we do a lot of the same things. Connect to Azure, select our subscription, select our resource group, select our logical SQL server, create the firewall, select our database name. I actually need to take all of this out of here. So let me code live. Why not? Make sure I update that. You'll notice that here under, we only have the vCore option, and the addition is just Hyperscale. That's what tells us then, again, you can choose the number of vCores, your generation of hardware, and you run new-AZ SQL database. That's the only differentiator for the Hyperscale. Now, in the meantime, you'll notice that down here, my demo DB has been deployed. All right. The third option here is how do you create a pool and assign databases to the Elastic pool? skipping past the connecting and the resource groups and creating a SQL Server. The new AZ SQL Elastic Pool commandlet is what we need to define here, passing in our pool name. And I actually haven't updated this for vCore. Hold one moment while I start making a list of notes. I need to Elastic Pool script include vCore, not DTU. So this is the older one where DTU, DTU min, DTU max. What we would be putting in would be, again, our addition. So we would need to be defining general purpose or business critical storage for our pool. Then we would be adding in, again, our number of vCores and what version of compute, again, Gen 5 M series we want to use, and run new AZ SQL Elastic Pool. Once the pool is created, then you can either define a new AZ SQL database, pass in the resource group name, the logical server name, the database name, and simply add in the Elastic pool name option. Or you can move existing databases into the pool by using the set AZ SQL database commandlet, passing in, again, resource group name, logical SQL server name, existing database name, and Elastic pool name. There are some other commandlets around Elastic pools, like get AZ SQL Elastic pool will list out the different pools that are available to you and the databases that are in them. So those are, again, under that platform as a service offering option of the single database and Elastic pools. Those are the PowerShell commandlets. I'm going to go for about another 5 minutes. So you have at least 5 minutes between sessions. The last thing I want to show you, though, is new AZ SQL instance, which is how to deploy a managed instance. This script comes directly off of our documentation page. There are probably a ton of scripts out on different SQL bloggers, websites, different things in GitHub repos. I want to just show you a few of the most important pieces. We're going to be familiar again with connecting to our Azure account, setting our subscription, setting our resource group name. What's more important in here is, again, we have to define a virtual network name. We need to define our virtual network addressing. Then we need to create our default subnet within that virtual network and set its address prefixes. There are some requirements around the minimum number of IP addresses required for a managed instance. So you can't set this to like 10.0.0.0/2, right? You need more than that. So make sure you're reading the documentation and paying attention. And if you want more than one managed instance server in the same subnet, you need even more addresses available. So managed instances require virtual network and subnet planning, making sure you have enough available IP addresses for what you plan to do with it in the long term. So we have under our VNet, we create a default subnet and we create a managed instance subnet. Then you can create your instance name. Again, you'll have to specify that admin username and admin password, not your credentials. Please don't put your Azure credentials in any of these scripts. we choose our edition, just like single databases and pools. This is our storage option, number of cores, max size of storage, compute generation. You also can choose whether you're using kind of a bring your own licensing model, or if you are just paying the default base price. You can bring your own SQL Server licensing if you need to. Then what you do is you create your resource group. Then you run new AZ Network Security Group. Then this is the word I was looking for earlier when I was talking about managed instances and networking. One of the things that it needs to create in the background, which you don't see in the portal, is a routing table. It creates the virtual network, has your virtual network subnet configuration. After you've gotten through that, and if you want to use subnet delegations, right, you finally have your subnet ID. Make sure if you are trying to build managed instances in PowerShell that either you understand all of the networking pieces behind it, or that you are working with someone in your networking team that does and can set this all up correctly. You'll notice that at the very end, after all of that has been set up, it's really simple to create the actual managed instance. It is a new -AZ SQL instance where we pass in the resource group name, the managed instance name, location, that subnet, our credentials, your compute generation, your license type. So notice managed instances, about 3 lines of code related to the actual instance, about 100 lines of code related to the networking. Here be dragons, be careful. All right, so that is just a quick overview, as quick as I can make it, about the actual deployment options and how to navigate all of the terms I've shown you on the slides as it relates to creating the objects on the portal and creating the objects in PowerShell. I do see a question out here about what is the most convenient way to make sure scripts still work 1 year from now while the Azure API has progressed in the meanwhile. There's no magic formula for it. We don't have anything that tells you, hey, update your PowerShell. As you can see, I have scripts that I've not updated. It's a manual thing. You need to be aware of what changes are made. Maybe subscribe to the feeds for the commandlets that you use most often. Make sure you have a consistent CI and CD process for deploying your databases if you do it on a regular schedule. There's no specific magic wand I can give you for that, unfortunately. All right, so we are closing in on time. I want to thank you for spending the last hour and a half learning about all of these different terms and options in Azure SQL. Remember that it is really designed to minimize the management and optimize, letting you choose performance, modernization, and new features. If you have any questions, please feel free to send me an email or connect with me on Twitter. I'm on there all the time. Please feel free to go ahead and download or even fork my repo. If you would like to contribute any scripts or any additions to the scripts, I would love to see some PRs out in my repo. And if you want to connect on LinkedIn, there I am. And that's it. That's it. I say that's it. Thank you again for attending. I hope that all of you have a great day here at GroupBy.
Thank you very much, Jess. It was an amazing session, and I very appreciate the repository too, because it's a dense type of content that we all like, and I will surely will copy and fork it and use it all the time.
Yes, thank you.
It was awesome. We loved it. Great job.
All right, up next, I believe is the one and only Rob Sewell.
Exactly. We have the magic Rob next.
Hi, Rob.
Hello, hello. Well, you're in good hands. Thanks so much again, Jess. Rob, you're going to kill it. If you need anything, I'm just going to be lurking in the shadows. So let me know if you need a hand. Emmanuel will be helping you on your moderating there, Rob. So good luck and looking forward to it. Talk soon.
Bye. Rob, the SQL DBA with a beard. Okay, we have a couple of minutes left. Would like to leave people get whatever they need before they get to the Rob session, which is on notebooks, PowerShell, and Excel automation. It will be very interesting because all things I like very, very much. That's amazing. Let's give it a couple of minutes and then I leave it up to Rob.
Ja. Jag kollar på ett seminarium.
Hello, Rob. I can't hear you. I don't know if it's just me, but let's use these minutes to check the audio. Check your microphone, Rob, please.